All right, cool. All right, so on to the last part, and then more questions as always. All right, so the other concept, because yeah, a lot of it is phrasing, and I think that the phrasing is important. It helps bring people on board and make sure that we are behind the same purpose. A phrase that I have seen sort of going on the rise in the last year or two is circular economy. And what circular economy means for green chemistry or chemical industry in general is a few things. So one is this responsibility for waste and responsibility for the end life of your product. So without repeating myself too much, we want to design for the circularity such that every time we have a waste, we can do something useful for it. So, for example, here we want to think about capture or release of gases to the atmosphere. Ideally, some capture. We can think about, even getting CO2 from other industries. So an interesting partnership that I've seen quite recently is between Dow and one of the cement producers, I think. And the cement is, or gosh, they're both steel and cement. In fact, they're producing big amounts of gases, and if we can get those gases in decent purity enough, they can actually be used as the feedstock for our reactions. And then the other thing to good thing to keep in mind is, the renewable carbon sources. Here I found this nice chart that talks about sort of three renewable carbon sources in the world. So first we have plant-based, air-based, so we can capture CO2 from the air. Although every time we do it, we do have to pay some energetic price because again we go against thermodynamics. And then man-made. So repurposing of plastics is important and will be even more increasingly important because we really want to think about every process no longer being like X to Z, but some form of a circle, such that the things are much more sustainable. Because especially if you add population growth as another part of all of it, things get very scary if we cannot recycle and reuse almost everything that we produce. So, what are some of the big decarbonization targets? They correlate quite well with the primary chemical market that I told you about, I think, in the part two. That's simply just because of their size, right? So, you can see that there is a very good correlation between energy consumption and production volume. And as we produce ammonia in a mind boggling amount, and it's needed for fertilizer, and then the second one will be ethylene because it's needed for a lot of industries, pretty much any industry that takes materials from chemical industry will have some ethylene being involved in it. It's a great polymerizing gas. There's also a big price that we pay in terms of energy consumption. And unfortunately, every time you hear energy consumption, you have to be thinking carbon emissions. So it will be certainly wonderful if we come up with some ways of making those processes clean. And the challenges here are huge because since the scale is so large, that also means that those are commodity chemicals, and it will be extremely hard to fight on things like price. A lot of industries are very sensitive to their margins, and it just would be really hard to say, hey, I'm making bioammonia. And by the way, some people do, and there are niches where it can work. But when it comes to the big decarbonization targets, and we don't include things like law regulation or carbon tax, this will certainly get tricky because in the commodity world, price is king. So ammonia, our biggest target. There are certain ways of thinking about making it more efficiently and cleanly. International Energy Agency had this nice chart talking about technologies that is very similar to what Opus 12 is doing. So electrochemistry and simple gases such as hydrogen, and then we need some synthesis with nitrogen. Right now we use Haber-Bosch, and it goes to really high temperature, and it's intense. But in the future, if we could use hydrogen being sourced from a renewable way, using renewable electricity, and then being able, which is extremely actually difficult, but find some clean catalytic way of turning nitrogen and hydrogen together with ammonia, there will be a huge, huge win for the world. And there are plenty of different R&D opportunities. I already mentioned, electrolysis that is needed for hydrogen production. We talked about biomass feedstocks that could definitely help us. Here we have, for example, lignin to aromatics. But what's important to notice is that a lot of the things are still very much in fundamental research stage, and maybe now we have some, emerging first plants. So progress is being made every single year. But when it comes to those big targets, like I said, ethylene or ammonia, they also turn out to be the hardest one. Part of it is coming with fundamental research. If we really find, greener and cheaper ways to do it, even incumbents will listen because they make new plans every year. And if there is a process that they are convinced will give them a better return on investment, they will follow. So this is one of those slides that I definitely don't want you to stare and try to understand anything from it because it's so tiny. But it again shows the map of the industry in a slightly different way. When it turns out that again we have a ton of different consumer goods and finished products, and they all originate in the same place. They originate in petroleum and natural gas. But a really awesome work that NREL did in 2004, they released this, I think, fantastic report called Top Value Added Chemicals from Biomass. And they envisioned this world in which instead of natural gas or oil, we use the basic feedstocks: starch, hemicellulose, cellulose, lignin. And turns out that if you have the right catalysts, if you have the right enzymes, you can break them into important building blocks ranging from 2 carbons to 6 carbons. And from there, you can make all the secondary chemicals and products just like you wanted in the past. So it's not that different from what I told you before, that we want to change the feedstock, we want to change the reaction, but actually the product will likely still stay the same. And International Energy Agency, the Bioenergy Division, did a nice update this year on that report, showing where are some of the relevant companies and which of those chemicals they're interested in using. So you'll be able to find this in the appendix of my talk. All right, so this part is mainly intended as sort of a general conversation about, how to survive in this space. What is maybe a good lesson, maybe good to do, maybe not that good to do. I agree that the structure could be better there, but I think of it more of as a general advice brainstorm, and there's definitely more research that everyone has to do if they want to do well in this industry. But like I said, I'm here to just tell you a few general things. So biofuels is one of those lessons that for me is very important for everyone to internalize, because there was a huge boom in 2005, especially around 2010. You can see the Amyris stock was trading at 500. But it turned out that if you cannot compete on cost on a commodity product, and fuels are certainly a commodity product, you're really not going to win. And a lot of those companies learned in a hard way. They were either to sold for pennies for a dollar, go bankrupt, or completely pivot to a different space. And the lesson here is simply choose your targets carefully. And yes, I showed you those big decarbonization targets, but as you start in this space, you want to be very cost cautious, and you want to know that you're selling something that people are willing to buy and often pay premium because it's worth it for them. Another big opportunity are plastics, the opportunity and the threat, naturally. It is kind of scary to think that 95% of plastics that we use, and this is a huge market, we're talking hundreds of billions of dollars annually, is lost after one use. I mean, a classic example here is a single-use plastic bottle. We open it, we drink it, we toss it away, oftentimes not thinking what happens with it. And 32%, so roughly a third of the plastic escapes collection systems, and the harm is estimated at $40 billion annually. The McKinsey report from a few years ago, I think, presented in a specifically dramatic way, where you can see that by 2050, we're going to increase our plastic production. And in fact, the ratio of plastics to fish in the ocean, if nothing changed, would end up to being 1-to-1. And that's by weight, which is crazy because plastic bottles are way lighter than fish. Their density is lower. So if you can imagine that in a few decades we could have the same weight of plastic in the ocean as fish, it's certainly a horrible world to live in. And oil plays a very big role here because as I showed you a BP projection, we know that electrification is working and we will consume less and less oil for energy, but we still need the oil for plastic consumption. So if nothing changes by 2050, we would have a fifth of oil being used for plastics. And I believe this number should be even higher because with things like COVID, transportation is going down, all industry is going down, but we use quite a lot of plastics, right? Like we need plastics for our single-use containers, we need plastics for medical uses, we need plastics for pretty much everything. So the share of the carbon budget, we were looking at 15%. Those are really some scary numbers. As I said, Carbon Tracker is one of those sources I definitely recommend if you want to go deeper into plastics. They released a report this year where they estimate the externalities of plastics to go to $1,000 per ton. And in their world, in their hope, is that people and companies and governments will realize it, such that we actually not going to go into the McKinsey prediction because we will realize how harmful those plastics are. And a lot of it is about going towards bioplastics, but part of it may be also, for example, just limiting our consumption. It's to be determined what's going to happen, but from our perspective, it's certainly a big opportunity because if we can make them in a sustainable way, if we can recycle them and we can use less oil and benefit from all the plastic material that we're using, it would be a huge, huge, huge benefit. For now, the bioplastics cost more. Again, this is slightly outdated. We're looking at the 2016 report, but again, they did a nice way summarizing how, at the moment, if you want to make the same plastic but from a biofeedstock, unfortunately, you do have to pay more. There are places where it is acceptable. There are customers who are willing to pay the higher price, but the closer you come to a commodity, the more you have to be just extremely and brutally cost conscious. So that's somewhat of a tough realization. On the plus side of things, I did a quick sort of search, seeing what's changed in this space. And as I've told you, a lot of incumbents are more and more interested in with partnering with companies that tell them, how to make plastics that can be recycled and can be advertised as more bio-friendly. So pretty much every company that you see here is either a bigger player like Eastman or is partnering with somebody like DuPont, Dow, or Ineos, for example, the British company. And we see a variety of different technologies that are happening here. There's a lot to uncover here. But the first thing to know is that the plastic recycling is split between mechanical and chemical. So mechanical is simply you chop it into pieces and you don't change the chemical bonds in between. Here I'm just listing the chemical recycling solution where you actually are changing the chemical bonding because, for example, you want to separate complicated plastics. So BASF, and Dow think a lot about it because their packaging is actually growing. Again, because of COVID, packaging is going up. And oftentimes those are quite fancy, complicated packages that let our food, for example, breathe. The way we package food, there is a special air permeable resin, but it also means that those are really hard to recycle. So there are some efforts, small companies and big companies think about how to make those composite plastics less complex or simply more capable of recycling. Polystyrene, again, you can think of your takeout boxes and insulation, ton of different ways. There are companies that are looking at it. And it's important to know that not all those companies are into so-called the biospace. It's not all just about the bioplastics. Some of it is about technologies like pyrolysis, where you're trying to get as much energy from combustion of the plastic and think about how we can recycle that CO2 such that we're just not polluting our atmosphere. And PET, plastic bottles, there's a lot of good activities there. There are companies that are looking at microbes that could potentially eat plastics, or we're talking about classic inorganic reactions, either lower or higher temperatures that could depolymerize. So depoly, for example, depolymerize, break the polymer of the plastic. And they are less known problems.
Mm-hmm. Sorry, there was a question. There's a question over chat from Colin. If you're familiar with a company called Pure Cycle.
Yes, I've come across them on research. Is there a follow-up to it, or I don't know?
Yeah, I was just wondering if their technology was substantially different than if you had done any kind of deep dive into what they're doing. I think it's fairly proprietary, but based on what I've seen, it's pretty promising. the plastic recycling process.
Yeah, I think what you just said is very important, that oftentimes it does get kind of proprietary very quickly. So it's kind of easy to, see what targets we're after, or like where the companies are partnering and with whom. But assessing technology is something that is way beyond the scope of this presentation, because you really do kind of want to be an expert and, maybe even have a chat with them to sort of understand the potential of it. So I don't want to weigh and say, oh, this is a good company, this is a bad company. It's more of like a starter of what's happening on the market. But I certainly appreciate the question. Thanks, Colin. Okay, so less known problems. As I said, a lot of this talk is about greenhouse emissions and plastics, but chemistry is so much more than those two problems. So here I just kind of want to say that the lesson is, it's so important to do your own research and pursue unpopular topics. I don't know if you guys are familiar with the Erin Brockovich story, or the movie starring Julia Roberts that came out based on Erin Brockovich, but she's pretty much unanimously known from the fight against hexavalent and chromium, which is a toxic chemical. So chromium-3 is apparently fine for us, but chromium-6, a different oxidation state, is extremely toxic, and it's been used for decades to prevent corrosion in water. And we know that it's causing some serious diseases. So Erin Brockovich was one of the people who created a lot of awareness of this problem. But sadly enough, hexavalent chromium is still being used, especially, for example, by U.S. government that, despite certain regulations on this chemical, excluded itself from its use. And I know all of it because of Solugen. And funnily enough, they became a US lobbyist to raise the domestic awareness of this problem, because in Europe, the authorization period for hexavalent chromium is expiring in 2024. And I think the US government is eyeing some similar deadlines, but there is actually no great technology to replace it yet. So Solugen is, again, increasing awareness and just trying to gather funds to work in this space. And I think I want to give them a shout out for pursuing paths that are a little less traveled. I wish I could tell you how exactly I uncovered those topics, but if I did, I would be a millionaire myself. The truth is it does take a lot of skill, and it does take a lot of good partners to understand where the opportunities are. I can certainly list a bunch of targets, such as NOx, so the toxic nitrous oxides, the forever chemicals that have already been brought up by one of the questions. There are really serious water contaminants, and I wish I saw more activity in this space. We have heavy metals. They are fortunately coming out of production, but if you go to the yearly EPA awards on green chemistry, there is still good research done. So there is potential for commercialization. And concrete, usually kind of different industry, buildings, but it's still, chemistry. And what's really awesome is the carbon negative, or at least carbon neutral concrete. There are many startups and people are eyeing this space as well. All right, so if you're a company, what you're really interested is funding. So again, a very, very brief overview of the situation here. Again, if you want to know more, I definitely sent you to that resource. The funding has increased from 2018 to 2019 quite significantly. But as you can see, the number of deals actually has not increased. And that means to me that we are seeing some form of increasing market maturity and awareness that maybe there aren't necessarily, more great ideas, but we see bigger need for, Series B. That's usually where the funds investments are a little larger, and there are good companies that are looking for expanding their capital, because again, everything is very capital heavy. So we had seen some form of growing market maturity, I'd say. In terms of top investors, when it just comes to the number of deals, a big shout out to Y Combinator and IndieBio that are strong partners of 50 years. Some other companies, for example, Viking or Sky Ocean Ventures, that I actually haven't heard much about. Just based on the i3 Connect database, they've been active in this space. And big companies, pretty much any of those companies like BASF and Dow, they are willing to put the money if they really like something, probably for some form of a joint venture or even exclusivity for technology. They're more than willing to invest in you. And as you start in this journey, intellectual property will be a very important part of what you're doing. Pretty much in any industry, it's the case. And what you need to know is that, again, it costs money. So kind of similar to the question about FDA regulation, it's good to understand this world and learn from others before you dive head on. So whatever you want to create, say you're in academia, it's good to start with a provisional patent application because it gives you 1 year to prepare for your non-provisional filing, and it's holding your place in line so somebody else cannot steal your technology. And then you have to wait for the approval times. And it's good to know that for some things, it's better to keep them as trade secrets. So you don't have to patent things. You can keep them as trade secrets, but then you have to make sure that nobody knows about a specific thing. So every time you talk to an investor, for example, you have to write an NDA. So those are very common and should be used as broadly as possible. And these days, there are actually even like templates online how to write a simple NDA, because if you say something without an NDA, you may lose your trade secret. So that's a big deal. Okay, so second slide. When it comes to IP management, the way I've once been told about it, it's kind of like creating an IP moat. So every time you apply for a patent, there is a risk that it will be rejected. So it's quite common to actually split your invention between different patents because you kind of want to separate your risk. And even if something, one of this fails, you still have the different aspects of the innovation being patented. And obviously the patents will be only as valuable as the invention themselves. So you don't want to get completely bogged down in the legal fights. You want to make sure that the patents are being used for doing good work and producing something useful. But as I said, as if ever industry without knowing about the legal side of things, you will not fare very well. So how to survive in the market, some general lessons, stuff I already been telling you about. So you want a partner. I think I've said it many, many times, but you are small and you don't have a lot of money. So every time somebody's willing to either help you non-monetarily, so with their expertise or with their connections or with their capital, it's all very important. Humility or realism will come as close second because it is a tough space and the incumbents are huge and they really know what they're doing. They've been in this industry forever. So you want to have a very strong understanding of the specific product that you're working on, far, far, far deeper than anything I'm describing here. And this way you can naturally, leverage all the kind of competitions. There's a lot of like green chemistry competitions and support programs like incubators. And lastly, scale carefully. You want to go towards larger and larger volumes, but often this will mean lower and lower margins. So start with a specialty chemical, the opposite of the biofuels. Like I told you in the lesson learned, you want to start with something that has probably a higher selling price per kilogram, because then you can wiggle a few dollars without anyone noticing and still be fine. If you go to a commodity, you'll be fighting over cents. An interesting strategy to survive as you're starting is direct to consumer. I have 3 stories here I want to tell you about. The first one is from Solugen. They created a brand called O2 Clean, and they used their hydrogen peroxide. They're really interested in big scale, but they realized that no one's going to buy commodity hydrogen peroxide at a high margin. So instead, what they did, they learned how to make wipes, because there are many people who are very health conscious as well as they're environment conscious, and they started selling them. So it's a kind of an interesting pivot, and it will obviously take you some learning and you need to know what you're doing, but it may be worth it to take a detour. And instead of, again, shooting for the huge volume, you want to find some nice niche. For Solugen, the cleaning wipes worked out very well. And in fact, they kind of stopped making them because the lessons and the media buzz that they got from this effort made them build the connections with bigger partners. And I don't think they're doing O2 Clean anymore, simply because they spun it out and they're focused on the hardcore chemical industry. But like I said, it's good to start small. The other one is...
I'll add to that. I'll add to that. So I think for them specifically, it was they wanted to prove to larger companies that there is a market for what they called bioperoxide, and that consumers care. And as a startup, they just needed to prove it themselves, right? So they started communicating around the benefits of bioperoxide, like how it all comes from plants. Again, they were able to hit that target consumer of very both health conscious but also environmentally conscious, willing to pay a premium, excited about kind of nice packaging. And they didn't just discontinue. They actually, the brand got acquired by a larger chemical company, and now they're the sole supplier of bioperoxide to that. So the brand actually continues. But it was never their strategy to, and I think this is the reason I'm talking about it. It's a lesson to other companies out there. Their goal was never to sort of be a D2C company. They just wanted to prove to the market that there is demand for that, and that's exactly what they did.
Absolutely. No, thanks a lot for that. That's exactly the story we're trying to get here. The two other examples of it would be Airco, or Air Company. They're a little newer. I wanted to ask you like what's on the picture, but if you have good eyesight, you can see it says vodka. So their big claim is that this is the first and only carbon negative vodka. So the scientists behind it, they're quite skilled in electrocatalysis, and they know how to convert CO2 into different chemicals. And I've researched this space. I was a researcher doing CO2 conversion to chemicals, and quite often you end up with ethanol. Again, it's all about separation. It's never just pure ethanol. You have the cost of separation, but I think that's a really interesting story, and you can buy them online. And you can say, hey, I'm drinking alcohol that is carbon negative because I really care about environment. So I think it is a really fun story. And the last one I want to mention is
Sorry, I'll add something here again. I was actually reading about them recently, and they're actually, again, a brilliant strategy where they can go after the first product. And I don't know what's their long-term strategy. I'm not that familiar with like the inner workings of the company, but that's something that historically and people have been willing to pay a bigger premium for because of the story of the bottle. It's a gift. There's this, and it's just the price that the consumer is willing to pay is like fully detached from the costs, right? And like whatever it's much more about the bottle and the brand. And I know they're going after perfumes, which is also another very high margin product that's very much detached from the cost of ingredients. It's kind of all about story and branding, which I think it's a brilliant lesson for many of the companies in the space.
absolutely. And their CTO, we overlap at Yale. We were in the same group. I was an undergrad, and staff back then was a graduate student. So I know that they are also involved in X Prize, and they're involved in the NASA program. One is about CO2 to glucose conversion, and X Prize is simply another way to say, okay, turning CO2 into anything useful. So yeah, they're good into creating those partnerships for sure. And last story will be Bolt Threads. So probably a lot of you guys have heard of a company. They've had a lot of tremendous success. I listed them as top 10 most valuable companies in that space. So they're making silk. Silk normally is, being used from those little creatures that you have to kill in order to get silk, the silkworms. It's actually a very sad story. So instead, they came up with a fermentation that lets you create silk. And again, it's about brand consciousness. It's about people who are willing to pay. And when they started, it was kind of similar to Sologen. They just wanted to see, well, can we prove it to anyone? Can we do something with it? So initially they were like, oh, maybe we can make a dress. And they looked into like how much it cost them and how little of fermentation capability they have. And I think somebody maybe initially as a joke said, well, maybe we should just chop it into pieces. And somebody said, well, how about ties? And indeed, at some point, they sold, I believe, 400 ties, if I'm not mistaken, at a price of like $300 or $400 each. And they sold out extremely quickly because it's just, again, such a captivating story. A lot of people in the Bay, they would come to wearing this tie to a party, and they would say, "Look what I'm wearing. This is a cool company. This is a cool story." At the back of the tie, each one of them had this label: 100% spider silk, made by humans, which I think is a tremendously great advertising. And the money that they collected from those sales helped them grow and expand. So 3 stories of, I think, really solid D2C strategies. All right, and something similar to this is media promotion and visible partnerships. So another shout out to Air Company, and they are one of the many who have switched into hand sanitizer production. What I think Air Company did pretty well is they know their people at Forbes, so Forbes wrote an article about that. But secondly, they actually did it at a cost. They donated the entire hand sanitizer to the New Yorkers. It was a time where New York was extremely hardly hit by COVID, And I think, if you're smart about it and if you know the budgeting, you should absolutely, do things like this to show your consciousness. And I think they did pretty well with this. Sologen is also pivoting to hand sanitizer, just on a bigger scale, and they're thinking more about supply chain. I was told that 50% of hand sanitizer orders are coming unfulfilled even now. So it's huge space. And if you know how to make those components, hand sanitizer is actually relatively simple. But some people who are getting into it, they're not trained properly, and they, for example, taking ethanol that has methanol in it, and there have been many recalls, which is really scary. Industrial grade denatured ethanol. So I'm glad that there are good companies like Airco or Sologen trying to do things right and using responsible and human safe components. Another story here to mention, for example, will be ball threads again. You can see that there are certain companies that I just know a little more about, and I think they're just rock stars. So they finally made that dress after ties. They had enough silk for the dress, and they partnered with Stella McCartney, one of the activists and person who definitely cares a lot about animal welfare. And instead of just making one dress for somebody who's not as famous, they made it with her, and they got a really nice media buzz. So as you started, I think some of the outlets that are a little easier to reach, for example, will be TechCrunch. I think they have a super strong pipeline with Y Combinator. So usually if you run Combinator, you can end up in TechCrunch, or Green Tech Media, something a little more specific to the industry. And I think, mentioned once, but competition and conferences are things you want to definitely participate in. There are just many of them, and just be active. When you start, it's often not about how much money you can make as much as how much visibility you can gain and what kind of partners you can get. And every time you can win a competition, that is a big boost to your credibility, because that's another thing that you have to gain, right? Like credibility is just a big currency that you need to earn in order to survive. Similarly, academic and government initiative. We brought Maine. Maine is not listed here. I guess next time I can add it to the list here. But there are plenty of foundations, such as NSF, the big one. They can give you grants, or they can partner with you. And if you do work with them, oftentimes, the supplies and access to instruments is free or at a very, very steep discount. So that, again, kind of answered this question: how can I survive without being cost competitive at the beginning? Really take advantage of those incubators. I think I also listed the here. So incubators and academic and government initiatives, because it's no brainer. You cannot just by yourself win against Dow Chemical Company or whatnot. So incubators, they can significantly decrease your capital costs, kind of similar as universities, because they will give you access to a lot of resources. So super, super important. And then, I am kind of repeating myself, but partnerships are just so crucial. Startups are flexible and innovative. Big companies, they have sort of complementary skills like customer base, channels, marketing strategy. So to survive, I really believe that startups must be useful not only for customers, but also for incumbents. Scaling will always remain challenging in any space. I think in chemical space, especially because the costs are just growing very fast. Every time you scale, it's like you increase by a factor of 10. So when you start, you're relatively small, you're doing basic research, you can use something like an NSF or small business grant, but then you start scaling it up. And so you need your Series A, for example. That's where things like direct to consumer can be a really good strategy to keep you going, so you can prove yourself and build those partnerships. And when you have those partnerships, you want to start leveraging them, start getting joint ventures, and then maybe we're going to like a Series C or something, and you get your real customers, your supply chain, so that eventually we can start thinking about unsettling incumbents. And that's something I added because the last time the slide didn't even have this scale, because frankly, at this moment, I cannot envision any of the companies unsettling incumbents in the next few years. Companies like Sologen are definitely greatly positioned to become more and more important, but it's still going to take them some time, unless we have, some super big inflections. And I think I do want to bring the point, right? Like crucial inflections may be needed. It could be regulation, for example. If there are some dramatic regulations, then companies like Sologen can suddenly become the cheapest solution for a lot of our problems. The other one is certainly genetic engineering. if it really turns out that almost every chemical that we make is somehow being done using biology, then I can actually imagine Dow and DuPont going out of business because they really have no skills in this space. But this is extremely hypothetical. Um, there may be majors, mergers, IPO, a lot of exciting stuff. But focus on what's on the left because it's a long journey, and you want to take your time as you travel. Right. So, what are some of the macro drivers for clean chemicals? I hope it's kind of clear as I'm talking in this presentation. But it's good to keep them in mind if you're trying to convince somebody why green chemistry and clean chemicals are the ways to go. So we have consumer and shareholder pressure. We are willing to pay a little more because things are eco-friendly, but shareholders start to care more. I mentioned ESG investing, right? There is a risk involved in this, and some companies, some big investment firms are getting a little uncomfortable funding petrochemicals because they're worried that it's just not going to be a good investment for them. Hopefully, there will be an increasing regulatory pressure, and that will bring the fear of competition, right? The incumbents are always looking at their back because they know that if they do not catch the next wave, the next technology, they will eventually be out of business. There's the component of resilience, and resilience means so many things, but being so dependent on oil is just bad for you if you're in a place that doesn't have a lot of oil, like Europe. You can also think in terms of resilience, in terms of toxicity or weather, right? Like as we grow more aware of the climate change, then we need to be resilient and we need to switch to things that do not poison our planet. And lastly, simply costs. In the long term, green chemistry is cheaper. So, always keep it in mind as you talk to people because there's plenty of good drivers that will prove that this is the way forward for the entire industry. And the choices ahead are certainly dramatic. You can see a lot of predictions, and despite COVID, I think that they will still probably hold true, and we can end up in very different worlds based on what kind of technologies we adopt and what kind of companies we invest. We may end up in the red zone, right, where the temperature will definitely increase more than 3 or 4 Celsius in this century, or instead we can end up in places where we're actually growing our population, we're growing our demand, but we're not growing energy consumption, and we're not growing greenhouse emissions. So I'm almost wrapping it up. Some final advice for investors and entrepreneurs. Definitely understand the chemical process that you're interested in, both technologically, economically. You got to dive so much deeper than anything we even scratched here because you want to become an expert in understanding, all the pitfalls and all the things that we talked here about. It's good by starting to look at processes where you can decrease energy costs, you can decrease waste, or you can shift to an alternative feedstock. You always want to work with the customer in mind because obviously that's the nature of business. If you cannot sell it, if you cannot make money in a few years, then you're out of water. And look for complementary skill sets. I truly believe that the space is simply too complicated for one or two people to understand and become a true expert in it. So as you grow, pretty much from the beginning, always be aware of where you are an expert and what skills you're lacking. And this can be anything from chemical engineering to synthetic biology, supply chain, or even accounting and law. You really want to understand and cover all these bases. So in summary, the principle of green chemistry is slowly taking over the entire industry. The problems are certainly too urgent to let incumbents just stick what they do and keep using fossil fuels. And chemical made biologically will likely revolutionize the market. A lot of it that I told you today is just a matter of pace. So hopefully you'll decide to get involved so we can speed it up, and in the process you'll make some money. The improvements in synthetic biology are fortunately decreasing the amount of capital that is required to make new chemical processes. So we can imagine that the growth and technological improvements will accelerate in the next decades, which is super exciting. And finally, I've said it many times, but successful companies must be driven by economics and not just the willingness to save the environment. So with that, I want to give some acknowledgments to 50 Years that invited me and asked me to make that talk. I learned a lot, and I really value the opportunity to have that space. Here are some of the people that I spoke either during this edition or some of the previous ones. And just so you know, there's plenty of sources. So when you get that presentation, you can click on the links and learn more about that.